Okay, so good afternoon. Going out in the last stretch of the summer school. There is still the panel. And even after the panel, I would like to show an editing tool for the UMR, so there will be another thing to do. But for now, I would like to say what other things we are doing in Prague. So maybe I should put it in some context, because if you have seen my lecture on Wednesday, it looks like we are on the completely opposite side of the spectrum in NLP, doing clinic representations. But yes, we are doing clinic representations. But at the same time, we are also doing language models. And in fact, we are leading a project that should bring Europe at least at the far side of the large language models which are now available in the world, and we should do it in a completely open way. So the goal of the project, which is called OpenEuroLLM, is to have an open, multilingual, European generative language model. And the stress is on several things. So first of all, it should be fully open source, meaning including the data. So now there are many so-called open models, but these are rather something which where we use the term open weight model. So you can have a model, you can download it, you can inspect it, you can do whatever you want, but you cannot get to the data which were used for actually training the model or fine-tuning it or instruction tuning it or whatever. So this should all be available openly, if not for download, at least for 100% inspection what was used for the model training. And this is of course related to the European regulation, which is the last point on the slide, which says that things must comply with certain rules in not to be harmful or have other unwanted properties. And the openness should do, if not 100%, it won't do 100% of it, but will do 80% of that, so that we will be able to say how the model was trained, from which data, and so on. Of course, the software will also be available, even though it will use the standard tools, but the weights, the scripts, everything that has been used, there are many ways how you can actually train a language model, not just a very standard dense type of model. Now, multilingual is another big focus, because obviously Europe is multilingual as opposed to the US and China and other big countries. Maybe we can compare it to India in a way, where there are also many languages that are spoken. So in Europe we have 24 so-called official languages. So anything that comes from the European Commission, which is sort of the government of Europe, should come in those 24. Actually, it doesn't happen that equally, but it should. But there are many more quite large languages which are not part of the 24. And we were originally asked to do 32 languages, which would be the 24 official, 8 of countries which are now in negotiations, which includes Albania, Turkey, Ukraine, and some other smaller countries. And then we added 5 more, so actually the 32 is no longer true, it's 37 languages, because we also wanted to add Norwegian, for example, because Norway is not part of EU, but it's part of Europe and actually has all the agreements in place which make it almost a full member. So this is sort of, as opposed to Britain or Switzerland, which are not so well integrated as Norway is. So we don't have the Romani language from Switzerland, but of course we have French, German, and Italian. The model should be high quality as possible, and in fact the goal, which I don't say publicly too much, but I said it yesterday, so I can repeat it in a smaller circle, that we know we cannot beat everybody in 3 years from now, because of course developments will be in those models which are available today, even the closed ones and the commercial ones and so on. But we would like to close the gap between what's available now in Europe, like the Mistral models or Silo models, or some of the OpenSci models, or EuroLLM models, which is a different project. And we would like to go for a relatively large model. You can imagine Llama 3.1, roughly speaking, and have it within 18 to 24 months from now. Now the project will run for 3 years, so at the end we should have hopefully a slightly better model as well. And the quality should be at least comparable, and should be comparable for all the 37 languages. Of course, this will not happen in full, but we would like to show that even for the small languages we can do better than the current models. So, for example, I was testing ChatGPT, which is instruction-tuned OpenAI model in various variants, and even if I don't look at the content and what it hallucinates or not, very often there are some grammatical errors in chat if you use it. Not big ones. They don't prevent you to understand. But if you do if you ask it for a longer text, like a recipe for one of the typical Czech foods, then suddenly in the middle there is wrong subject-verb agreement. Right? So these things should be at least improved for all the languages, including some of the smaller ones which are in Europe. You probably all know what is a language model. Just to make sure that you know what I'm talking about, what we actually do to get related to it. Normally, people today see, of course, because that's what's publicly available, is the interactive versions, the interaction-tuned versions of the base models, which are also called conversational LLMs. So ChatGPT, Instruct-tuned Llama, DeepSeek, with reasoning. All these models are interactive models, and somewhere behind them, or somewhere on the way to this interactive model, there was what's called the base model or foundational model, which is a model which is trained on the textual data only, or maybe text and code or text and image, but it's not trained on the interactions, right? So if you use such a model and you replace by such a model the chat capable model, it will not answer your questions. It will repeat the question, or will extend the question, will extend the text. That's all what the base models can do. But it won't be very good at answering questions and doing summarizations and so on, because it will only, sort of mimic what is seen in the training data, which were long sequences of text. I mean, sometimes, of course, you have texts where you have questions, like you have FAQs from the web. There is a question and answer. So maybe some of them will be, these models will answer sort of these questions, but it simply means that they remembered the questions and they can generate the text that follows. Now, so the goal of this project is actually to build this very good, high-quality, multilingual base model, because everything then goes from there. You can, of course, continue training it. You can fine-tune it. You can, of course, make it interactive. You can add more languages to it, and so on. But you have to have this good base model. If you don't have a good base model, you will have an interactive model, but it won't be good. So this is what's the task of the OpenEuroLLM project. Now, there is also a question when we talk about these models and about their sizes and where they can run, how they can be used. What is actually, how do we measure large language models? And the answer is that mainly the numbers you see when you go to Hugging Face and there is a list of large language models, you see numbers like 405 billion parameters, 70 billion parameters, 34 billion parameters, numbers like this. So this is the number of the parameters. But what is important is what a parameter means and how big that parameter is, because that actually then translates to the actual size of the model in bytes, right? So it depends what is the precision of the parameter. You can have a 32-bit parameter. Probably nobody does that anymore. Then you have a 16-bit, 8-bit, 4-bit. Some of the models actually do use variable size. So there are models which claim they are 1.58 bits. I think that's the smallest number I have seen. So based, of course, on the size of the parameter, then when you multiply by the number, you actually get the size in bytes. And that's important for running the models, because then if you have a GPU card which has 24 gigabytes of memory, then you know which models can be actually run on the card and which cannot. But of course you can run it on the 4 cards which share the memory, so that's how big models are now being run. That you actually can put it into several of those cards and they share the memory. And there are other ways how to run larger models, but it is important to know what the size of the model is. So in our case, we are actually the biggest model, of which, of course, we will make the small variants, will be roughly the 400 billion model. So that's where we aim. The other parameter, which okay, there's another parameter which you have to take into account, and which I was actually surprised some time ago to realize that actually, even if you imagine you have a model which is I don't know, 16 billion parameters, it was quantized to 4 bits. So you say, okay, so this is 8 gigabyte model. So this will fit easily my 16 gigabyte card. Well, it could, but you also have to know what is the buffer that the model is able to process. And the buffer must be in memory when you feed it, the prompt and the data, whatever you feed it as part of the prompt, is the buffer size. And that buffer size is converted to embeddings, of course, every word. So even though 8,000 words seems nothing in gigabytes of memory, if you imagine the vector for each of the words, it's quite a lot of memory. So in fact, the buffer and the lengths of the context that the model is able to process significantly reduces the space available for the model on the card or on the set of the cards. Yeah? So that's an important parameter. So in fact, and we all know that if the model was trained on larger context, you definitely want to use them, because then the model gives you much better results on many tasks. So that's another sort of disadvantage of having the larger buffer, that you also need a larger hardware for that. Now the other thing is, in training, is not only the size of the model, but it's the size of the data. I mean, these are related. If you want to do 400 billion parameter model and you give it a million words, it probably won't do anything, right? But if you have a 1 billion model and you feed it 15 trillion words, it probably won't be much better than if you treat it on just 1 trillion words. No one knows the exact formula for how much data is good, because it could depend on many things. And actually, we have experience from machine translation training, but based on neural models, but not LLMs, but the standard encoder-decoder models, where it made a huge difference just based on the way that you have cut the data into blocks and you fed the data into the model. By different data, I mean the native translations, the direction of the translation, synthetic data, and so on. And the difference in blue score was up to 10, and just by segmenting the data. So the people who are from our department know Martin Popel, who was the author of the paper in Nature that we have beaten people on translation. And actually we have beaten people just by using the plain transformer, but feeding the data in an intelligent way. Of course, we don't know what the intelligent way is, but we experimented with it and it made a big difference. So I would assume that even for the decoder only, the generative models, this could also make a difference. Of course, for this we don't have enough compute. I would say not even in the world, well, maybe Amazon, but so we cannot really experiment to such an extent as we were able to experiment with parallel data from machine translation, but it could make a difference, right? So we don't know the exact size of data. We actually need to have a good model. Maybe it's not 15 trillion, maybe 8, maybe 4 would be okay. So we know from the papers from Meta that Llama was trained on 15 trillion and has the 400 billion parameters. We might do less if we don't get as much compute as we would need for the big model, but we still believe that the scaling laws show that maybe we do not need so much data. On the other hand, we have available that amount of data, so we could do it. Multilingual. So we have enough English plus these 37 languages. Now we are generating synthetic data, so we will have more data that we can ever process. So it will be important to decide how to structure the data, how to feed the data, whether English first, all of them together, what chunks. We will have to, of course, do it on much smaller models and hope it will translate into the big ones. So now, so this was just an introduction about language models and some of the issues that arise in training. This is back to the project. So we have 20 partners in the project, which is, of course, a complicated thing to manage, but they are good. They are good partners, I think. So we are the coordinating partner with Charles University, and we have 5 other academic institutions who have experience with language model building. So Tübingen with the Alice Center, which Alice is a European Association for Machine Learning, which is quite well known. It's very hardcore machine learning people. We have Eindhoven, who cooperates with SURF, which is the Netherlands Supercomputing Center, has experience with building models and also with the regulation, with the making models compliant with regulation. Helsinki is very good at the machine translation. Where Tiedemann, you might know, they have this MT Opus website with lots of data and models for machine translation, so they will take care about the multilinguality in part. Then we have Turku, which is probably one of the most experienced universities in Europe when building models. They cooperated with Silo on the Toro North European models, the Viking models. And then we have Oslo, which is mostly involved also in training smaller models, but in data preparation. Then we have companies and sort of semi-commercial research centers. So Fraunhofer, you might know, it's a big network of private research centers, industrially oriented. You can imagine Germany, machinery, cars, and so on. So this is the AI or IT-oriented Fraunhofer Center. We have Jülich Forschungscenter, which is connected to the Jülich Supercomputing Center in Munich, and AI Sweden, that's a new nationwide center for artificial intelligence in Sweden. 5 companies, and the most important is Silo AI, now called AMD Silo AI, because AMD has bought them. Even though AMD is probably not building models, they let them work in the open source community. My guess is that AMD wants to see how big models are being trained on their hardware, and then maybe do something about it, because obviously, but that's just my feeling. It could be otherwise. But there is Aleph Alpha, which is a German company also who has made models before, and we have small companies, Alamind, Lighton, and Promsit. And Promsit actually also works on data. And finally, we have the supercomputing centers in Europe, because of course all of this will be run on public infrastructure, because it's mostly public money, co-funded from industries, but there's a lot of public money involved, and the HPC facilities are also public. And we have Barcelona Supercomputing Center, the Italian Cineca, CSC, it's Finland, that actually runs on AMD cards, everything else runs on NVIDIA's. And SURF runs on NVIDIA's as well, and as I said, Jülich is, we don't have the Jülich Supercomputing Center directly, but we have the research branch. And then Alteryx is a coordination organization. The LT stands for Language Technology, and this is like a pan-European organization which was just created for these projects to coordinate across many of them, and also make sure some sustainability, because usually when a project ends, the data goes away, but they should make sure that actually the data, the models, that everything we develop stays available after the project ends. So this project is for 3 years. We started in February, so we will run until January 28. And we are not alone. So you might question, and I'm sure it was in your head, if we do this base model, what it will be good for, because no one will be able to ask questions. But we have a sister project, which is called LLMs for You, which was just in the same call, and they have even more partners, and they should do all of this extra work for which we will provide the base model. Instruction tuning, fine-tuning for various domains, specifically security, defense, medicine, healthcare, education, whatever the companies there are interested in, right? So we don't care much about that, but they will start with the open models like Llama, but eventually they will switch to whatever we will be able to provide. So the actual funding for all these, and there's a coordination project led by the LTD. So altogether there is about 80 million euro involved in this. I mean, still, you know, if someone was interning at Meta or Google might say, well, this is nothing. But this pays about 100 people for 3 years in Europe, right? This is just for the people, essentially. So I'm always saying, you know, we don't need 100 people even to run a model training. We need like 2, you know, one who steps in for the first one when he goes to the pub, and that's it, right? So, okay, of course we need a little more. We need people for the evaluation, for the benchmark creation, and so on. But for the core groups, we actually have 2 core groups for the model training, and they together might have 15 people. So from this point of view, that's okay. Now it all depends on the compute. So if we get enough compute, which should be free to us, at least from our point of view, because we're on these public HPC centers, I think the value of that would be another 100 million euros if we get all we need. So it could be more, maybe, because they are now buying additional hardware. By 2027, there should be 5 times more capacity available in Europe for GPU power. So if we get that, that will probably have even higher value. So it's not that small as it might look like, right? And then of course there is a whole network of other projects. So Deploy AI, which would build like the European Hugging Face like thing where the models could be stored. I mean, of course we will put the models to Hugging Face too, but just for the sustainability, there are many others that can help us to actually get where we want. So we should develop these open and quality foundation models, and then together with the other project, they will be adapted. Yes?
Yeah, just a small question. So the difference between OpenEuroLLM and LLMs for EU is that OpenEuroLLMs develops foundation models only, right?
Yes, yes.
You do not continue pre-training on base models developed by...
We will probably have to do some fine-tuning ourselves before the LLMs for you have developed sort of the best data and all of it, just because for the evaluation. I mean, we have to run like continuous evaluation, how well we are doing, you know, count of branches which do not lead to good models, and for some of those tests, the base model won't pass them at all, right? So for that reason, we probably will just get some external data, do this fine-tuning, and then run the benchmarks. So we are still in the phase of selecting which benchmarks to use, both for the continuous quality assessment and determining the scaling clause. And once we have that, we will build the final model, and then hopefully we will have more benchmarks to run. And also the sister project will be able to develop all the other like final models. And of course, part of this effort is also that was written in the proposal to contribute to EU's digital sovereignty. And that was, of course, the call was made before DeepSeek, long before DeepSeek, but obviously this still holds, right? Sorry, right? Because, and maybe, as I said yesterday, the scope of digital sovereignty might have now be extended to almost the rest of the world. So, because it's open source, we will also cooperate with the community outside of the project. So it will not just be the 20 partners, even though there are companies. Normally, if you have companies within a project, you very often want to be quite, close, because the companies do not want to leak any information about what they are preparing, and so on. So there are lots of NDAs to be signed and so on. But since this is an open source and the result should be open source, we decided to invite people from the outside as well. Now, we are somewhat limited by the rules of the EU, so if we have someone non-EU, we have to actually ask for permission and so on. But we would like to have people who actually have experience with building models, right? So we engage some people you might know, Noah Smith is one of those. Michal Valko, who is originally from Slovakia, now back in the Czech Republic from Meta and DeepMind, and many other We will just consult, not that they would work for us really, but we hope to be able to establish such kind of community also for the future, because obviously once we are finished, there will be better models, do better reasoning, do multimodality, which is not our task, and we want to have people knowledgeable in how to build these models, and maybe we will form different consortia in the future. We also cooperated with a project which is called EuroLLM, which might be funny because we added open. They are also open. They are by definition also open. We just stolen the name. And in fact, they are led by the University of Edinburgh, which we couldn't take into our consortium because of Brexit. So UK hasn't signed an agreement about Digital Europe. So, and there was no way to get the University of Edinburgh into the project. So at least we will have them as an external. And we already jointly applied for some of the compute facilities, and we got 3 million hours, which we will use jointly with them. And they already actually have pretty good multilingual models for the 24 languages. And then some other organizations and communities. For the computing facilities, we will of course ask the 5 centers, but also the French one, which is quite big. They are not part of the consortium, but we can still ask for compute. Europe is now building what they call AI factories. And the AI factories will be a combination of new hardware, which, as I said, should make the hardware available in much larger quantities, about 5 times the current capacity. That should be available sometime 26, 27, so we should still be able to use maybe part of it. And the members of the centers in the project should help us to sort of technically be able to use the centers, because sort of unfortunately each of these centers have different setup, both technically and in the ways how that data can be transferred. There are different speeds of how to get the data there and so on. So it's not really possible to use the 5 centers like at the same time, like federated learning is impossible. At least, I mean, that's what I was told by all the people in the project, that let's not try it, because we would burn lots of cycles on testing, and then we would see that it's much slower than just try to get one of them for some part of, a couple of months, and then maybe move to another one, but not to do it at the same time. And I think the allocations and the bureaucracy is also not very friendly to synchronously allocate capacities. So for the moment, we have these 4.5 million hours plus some remaining compute from before. We will be asking for much more. We have done some calculations. There is actually a pretty simple formula how long a dense model takes to train. If you multiply the number of parameters, the number of data, and multiply by 6, you actually get the millions of GPU hours. So it's easy to know how much we need. 4 million won't do it, but it will. For now, it works. It will do it for the first 6 months when we do small models, like micro models and mid-sized models, where we would like to try, for example, the data sequencing. And to train a 1 billion model is 1 week, maybe less. So that's what we are doing. We are also generating a lot of synthetic data with using this 3 million thing, together with the Euro HPC, which is of course aimed at the smaller languages. So Czech is part of it on the border, but hopefully we will get some more data for Czech as well. I mean, for Czech we have 42 billion words, so very far from a trillion, but still quite good data. We might need more, but there are much smaller languages like Estonian.
Yes, I'm wondering if you're only using and generating synthetic data, or you're also conducting some hybrid data.
What do you mean by
let's say?
hybrid, like multimodal?
I mean synthetic, but with human validation, and also creating data. So, for example, creating instructions for fine-tuning models, etc.
Well, we probably don't have a chance to actually manually check the synthetic data, because we will need to generate billions of them. And for that, we will use the open weight models mostly, and then we will iteratively use our own models. So we will see how that works. Yes, we will need instruction tuning data, but again, that's the other project that will be focused on that. We will only need them if we want to demonstrate some capabilities in the benchmarks. So we will just get some standard open instruction data that are available.
And what about data collection? Because you mentioned, of course, some sources of open data, but are you also seeking, for example, cooperation from institutions, publishing houses, etc.?
I will show next slide about the data, because of course data is very important. So this is this slide, so we will use only data that has, textual data, because we are talking mostly about textual data. Textual data is a problem because 80% of the data on the web has a copyright, and then maybe 60% has a copyright which is restricted, right? So you have some CC0, CC BY data. The CC BY we even cannot respect essentially, because we can have a list of URLs, but really that's all we can do. And then there are data which are copyrighted, and we are just allowed to use them because there is an exception in Europe now too, like the fair use in the US. We have a text and data mining exception which we can use, but there are some restrictions on those data as well. So we have to be careful about what we can do, but we still call it sort of open source in the sense that legally it can be used for training models. There are several data sets which are quite large and quite good. Like the FineWeb 2 is probably the best data set available from Hugging Face, which is now multilingual as well. And also what we call the HPLT. HPLT stands for High Performance Language Technology. That's another project which incidentally I'm also leading, which started 2.5 years ago, and this is pre-ChatGPT, right? So the goal of the project was to collect data and build encoder models. So now the models are sort of on the side track. We will have to do them because contractually we should do them. But it's sort of refocused on data, because we knew once we go for this decoder model, the generative models, we need lots of good data. So we are really focused on data collection, not on crawling. So we were just taking data from the organizations that do crawling, and two of them are big, Internet Archive in the US and the European branch, and Common Crawl. And if you look around, essentially all of the data in Hugging Face somehow contain part of Common Crawl. So Common Crawl is actually the #1 source. Also, we found out that after the data cleaning, which was like re-ID the language, most of the data from the Internet Archive had wrong ID. Common Crawl sometimes true, right? It depends how you take the ID from the original website. Okay. Cleaning. There are many artifacts on the web, so it's not only about JavaScript. It's pictures, videos, the templates, like the header, footer, menus, and so on. Some of it you want to keep, but most of it you want to get rid of. Then the topic detection, you want to at least mark data which some people might not like to be in the models, right? And so on. So that's actually a lot of work, and people do it with various levels of success. Common Crawl seems to have pretty high resulting, I don't know the English word for it, like in Czech we have a very funny word. When you take 100% as the source, and we get about 15% of 15 to 20% of the volume of the data is the clean data, after deduplications and cleaning and whatever. From the Internet Archive, this was only about 7%, right? So it's less than half of the success rate of how much we can actually get from the web data. Still, it's a huge amounts of data. So, for example, the Internet Archive volume itself was 7 petabytes of data in the source raw format. From the Common Crawl, it will be close to it once we get all of the data. So we actually work with the people closely. We know each other. Common Crawl, essentially, it's a US foundation, but it works from Europe. So we actually physically meet and talk. We also talk to the Internet Archive Europe people. We also talk to Open Web Search, which is another European project which should have, do Google-like search. I don't think it will be successful, but it was quite successful in setting up continuous crawling of the web. Now again, they cannot give us the data because of the restrictions on the web, but we could use the data in some restricted setting. So we are looking at possibility how to do it, but I think they won't beat Common Crawl anyway, because Common Crawl has such a great experience with it. Also, the good thing about Common Crawl is that they are actually very careful about the legal issues. So if you take that data, you can be almost sure that no one will sue you just for breaking the basic rules about which data can be used, right? I mean, people can still sue you if you do a model which will regenerate the Hollywood movies, right? But at least, you know, from the textual point of view, they do respect the opt-out mechanisms that people can do based on the European exceptions and so on, right? So that's what we don't have to do. We just get the data and do the screening and other stuff. So I already said yesterday, I think the Nobel Prize for AI shouldn't have gone to him, should have gone to these people at Common Crawl, because without them there would be no models, essentially. So, and it's 6 people. I mean, Common Crawl is 6 people, which is amazing. So, anyway, of course, these low resource languages, they are still not there because simply they are not on the web in such quantities. So we will definitely look, I mean, the first step is the synthetic data, but we are trying to look at where there could be legally obtainable sources of other data. And it's very hard, actually, to get to some. Because if you find books on the web, that's usually illegal, right? If you go to the libraries, most European countries have a law that the library can do text and data mining on their collections, which they have in their archive, but they cannot give the data to anyone else. So, you know, I cannot imagine, you know, Czech National Library buying the Jülich Supercomputing Center to claim it's part of the library and then run language model fine-tuning on their own data. This won't happen, right? So, in fact, we cannot use those data. I mean, maybe if we find some way in the end to do some applications, like for education, we give the library the final quantized small model which they can run on their premises. They might do some fine-tuning if we help them. But that's all we can hope for. Right? Even if, I mean, there are some books, of course, which are old enough that they can give it to us, but the language is typically old. So it's not often, it might actually damage the thing if you look at it from today's perspective, because the language develops, right, over years. And I think the library has a rule that, for example, for newspapers, they have to be at least 150 years old to be reasonably sure that there is 70 years after the author's death, which is the legal limit, right, for free work, copyright-free works, and so on. Anyway, so that's it, and then it's the evaluation. We already talked about it. Evaluation will be done on current benchmarks, but since no one believes them anymore, we would also like to bring a set of multilingual benchmarks, maybe a smaller set than people use today, but certainly question answering, reasoning, translation, some other tasks, but in all these 37 languages, and checked by people, not only just translated from English, because some of them might be culturally conditioned, and we don't want to you know, answer questions about Hollywood movies if you do it in Estonia. You know, there will be some work. We have a dedicated work package for benchmarking and planning and data collection and checking and so on. So we should also come up with a good tests, and we also want to keep them secret, actually. That will be the only non-open part, because we want to make sure that no one can train on those data, not even ourselves. So we will have to make sure that also that group doesn't show it to anyone from the project, because people are what they are. So we will probably release the models as we go, even though they will be small and not very good, but just for people to, you know, to publicize some work that we have done. Of course, we will try to be best in the category. So if we are in a category of 2 billion models, we want to be, you know, on top of that list. We'll see how we succeed. This should actually come up very soon, like maybe in the summer. Then in the fall, we should have slightly bigger models, maybe not for all languages. Certainly, first models will be English. And then we will see what happens. And next year, we should publish some bigger models. So that's it. Thank you very much. Any questions? Yes.
Yeah, I'm thinking like it's for known like best performing models on the market, the data is not disclosed or not disclosed fully. So my question is there confidence in the group that using just the legally available data, like clean, open data, you can achieve similar quality?
We don't know. We are just hoping that we could. But if we can or not, we will see. We will see, and we will have to be very careful about the benchmarks and the claims that we make. But we are hoping we can do it. Now, of course, there is no green open data actually in text. Right? But at least in the data that we will have, and people will be able to inspect that actually there is no, stolen book in the middle of the data. So if the model suddenly recreates something, at least we will know that it's the intelligence of the model, not the fact that it remembered something. And of course, we have the way that we publish the data. We always say that if someone found something which is infringing copyright or privacy or anything, then we will take it down. Of course, it might be difficult once we have the models trained, but there is a research track that tries to de-train models, on sections of the data which shouldn't be there, right? So hopefully this will somehow be put together at the end, that we will be able to promise that as well. Because otherwise the European regulation would not allow us to actually, would allow us to use it for research, but this is not about research. This is actually about giving the European, if it's open, right? So, but the official goal is to giving the European industry, especially the small companies, easy to use language models, both as an API by someone who will run them, or even on premises for applications where the data should not be seen by anyone over the internet, or simply by cell phones, because it will be possible to do so. Yes?
Can you say something more about the benchmarking? I thought, other than that, it was very interesting, your comment about no one believes in it.
Yeah, well, the reason why people don't believe it, they think that even if there was some effort to make the benchmarks independent of the training data, that's the usual way that we were always doing the evaluations, right? Yeah. We have a tree bank, and then we know that there is part of data which was not used for training. Now in LLMs, this is very hard to say, where this data comes from. And even if people created a new set of question answering data set, but if they put it on the internet, how can you make sure that some of the models haven't seen it? I cannot say either, because if you get Chinese data from China, which contain some of their test sets, how can we tell? No one from the team, I think, knows Chinese. One of my colleagues knows Chinese. But he can, there's no way how he can search, or maybe he could if once we have the data available and installed for checking, but it's very hard. So we believe that even unintentionally, many people have actually used the test data, or at least the answers in the question answering data, for training the models, and then of course the test results are skewed because they know the answer. This was a problem with machine translation, right? You had you wanted to have not artificial translation, so you typically took something in English which was native English, written by someone who had nothing to do with NLP or machine translation. And then you translated this by using your sort of secret translation agencies, which no one knew about, into 20 languages for checking, testing your machine translation. But the original might have been posted somewhere on the web before, right? So you would have to hire a novelist or a writer, a technical writer, whoever, who will write English text for you completely anew, without looking at the internet, not copying anything, maybe then you would have data which would be not tainted. Because even if it's not translated, even if the translation was not available for the models to be trained on, the English might have been available. So for translating into English, as it used to be the case with when you used the search channel model, the English data, if they were the test English data, if they were seen by someone in training the language model, would help tremendously to get better scores. So this problem is here for a long time, but it was not so serious because typically the data was not just the whole of internet. Right now, when we have the whole of internet, and people still, crawl the data, the closed models use data which we don't know where they come from. So as soon as you put the data on the internet, you don't know whether Google will have the next version of Gemini having those data in.
I also want to add that actually the largest benchmark set that's recently published are actually funded by the companies that generating these big models like OpenAI,
Yeah.
Microsoft. For example, this morning Meta acquired Scale.ai, which generated the humanity's last question set or something like that recently. So it's probably the Meta executives or Meta engineers have full access to the entire data set by hand.
So from the business perspective, that we often, when we cooperate with companies, and this is also like long term, this is not because of LLMs, this was even before. The companies look at us when we tell them the whole story, how we have to keep the test data, please give us some data, but never, show them your engineers, and they always look at us and say, well, why all this hustle and fuss about this data? And we say, well, for our papers, we cannot do otherwise because no one will accept the paper when we cannot guarantee that the test data was not seen in training. But they say it doesn't matter. I mean, the data, for our purpose, I mean, our customer is the ultimate test, and we don't care how we get the customer happy if he's happy. Right? So they don't care about this.
Yeah, they never do.
Science rigor, and happily use whatever is available.
If the data is all the data is on the internet, they don't care. But but if they are new, they have new things. They have to care, right?
Right.
Oh, they care about their own data. They shouldn't get anywhere, right? So that's another fight with companies. But if we have a model which can be easily run on premises, actually today's models can be run. So that's not a big deal. I mean, we are running in our department a relatively small cluster. We are running all of these models from Meta 70B, several variants. Llama 3.3, 3.1, of course, with the DeepSeek, Quen, everything in one or two GPU nodes. Not the big one, not the 400 billion one. We cannot run that. But almost everything else we can run locally. And so you can buy a Mac. Actually, I was surprised. I don't work with Macs anymore, but you can buy a Mac which is 1,000 gigabytes memory together with some GPU card, which is slow card, but you can run a big model on it, right? And for inference, you don't need so much speed. So for the inference, I'm not worried much. I mean, people will be able to run it. I mean, we soon will have a phone which can run 70B model. Sure. I mean,
Yeah, why not?
15 years ago, could you imagine that you will have, I don't know what this is, 16 gigabyte memory? Okay, so yes, the benchmarking is an issue, and we have a whole team working on that from various points of view, and hopefully we will be having them. Now, we still have to find out how to release the data or how to test it, right, actually. Because typically these shared tasks, I mean, there are many shared tasks, right? I mean, everybody was organizing some or running some. Usually they rely on your integrity that, eventually they give you the data and you run your code on the data, you get 2 days to run it, and then you should return the results, and then someone evaluates it by some metric. But with this won't be possible to do it that way. So we will have to find out how to do it otherwise. And in fact, one of the shared tasks we ran, I think, was the 2017 universal dependency parsing task. Someone was willing to give us their cluster and set it up so that people would have to submit not the data, but the software. So we didn't have to show the data to anyone. We just defined the interface. They have to submit a Docker instance of their code with prescribed parameterizations. We told them on which virtual machine this will be running. They submitted it. We pushed the button. It ran, and it gave us the number. Right? So that way they didn't see the data. We could reuse the data at least once, and then of course after the 2018 task we release all the data. But we sort of tried how to run a thing like this. Now, of course, this was all CPU based because there was no language models. Now it will be more complicated because you will need a set of GPUs to do this. Some of the models might be big, some of them might need a lot of context, and so for some of the tests. But there will be one way. So if one of the HPCs would give us this, then we should be able to run like really fair testing on those models, which would be interesting, but again, not sure how much the companies will appreciate that. Certainly from the scientific point of view, it would be interesting to be able to compare the commercial models with the open source models on such clearly untainted data. But it will need a lot of effort, I think, to actually be able to do it. Yes?
Yes, so just another question. So from my experience in creating Polish large language model, because I was responsible for data creation and correlation.
There's a lot of noise here.
Yeah, from my experience in creating Polish large language model, Plum, right?
Yes.
I have an impression that the existing data sets are not enough. So I'm wondering, for all these 32 languages, what are you doing to make this data more, of course synthetic data is one thing, but also, more high quality data. Do you have some funds in your project to fund institutions, or what do you do?
Well, no, of course I got lots of emails since February. People offering data or collaborations on that because they wanted to have the models good for their language. Poland, Maciej sent me a couple of emails, other people I know actually. We are sort of in the Google situation in a way that we cannot care about the languages individually. That's really that we don't have capacity to do that. Even we don't have good rules how to tell other people. We have the software, so it would not be that difficult to say, okay, here is a GitHub with all the cleaning software. If you have HTML here, right, with all kinds of dirt in it, and you run the software and then give us the result, that might work, but we haven't set it up yet. And I'm not sure if we'll be able to do it within the 3 years. We will still be cleaning data, so we might get some experience that will allow us to say what I just said, right? So here's the software. Actually, the software is open source. You can have it today. But we will have to be very careful. In the HPLT project, we cooperated with was it Slovenia and Slovakia, and we sort of look at the data, but it appeared that all of the data they gave us was like 90% contained in what we had before from the Internet Archive and the community. So, but I agree there could be some very interesting national data, copyright-free, from government institutions, which normally cannot be crawled because you have to have something, but they are open, and that would be interesting to have.
Yeah, of course, I also that sovereign data is, of course, of better quality if we have better quality data, right? That's why I'm asking.
No, I agree. But also, we are not building monolingual models. We will, in the Czech Republic, we'll probably also build, we don't have a good Czech model, as not nearly as good as the Polish one, but that will be a different story. Now, this should be multilingual. The experience shows that if we do it right, the 37 language model will be better on Polish or Czech than any other bilingual model, right? Polish, English, or English. You have to use English anyway, right? in those models. So a monolingual model typically means bilingual, right? That you have English and the local language. And even then, the multilingual model will be probably higher quality with the same amount of data. So we would rather make sure that this is the case. We do not damage the English results on those multilingual models, because that's what normally happens too. And then hopefully everybody will be happy and people will not feel the need to do monolingual models, because we will be better than, well, not all of them, but at least most of them. So that's the current approach. So that's why we are keeping an eye on the developments on the data side about what the individual countries are doing. We have a long list of monolingual language models and the people associated with them, and at some point we might contact them, for example, to help us with the benchmarks for the languages, because typically the Czech Republic is also one, like Czech, it's developed not in our university, but Brno, in Brno. They have a Czech benchmark, which was sort of natively created. So we just can't collect them because they are different in different countries. But we might ask people, please do a benchmark of this type, this type, this type, because definitely to have experienced people will be better than just to ask. So. The HPLT 3.0 collection, which should be published this summer, would be about 3 times bigger than the 2.0. So in fact, that should be more than we ever can process on the compute that's even available in Europe as a whole, right? And so we will be selecting from that, plus we will have the synthetic data for the languages, which still would not have enough. But I don't think that's the case of Polish. We probably have a lot of native data once we have this HPLT 3.0. Any other questions?
Well, I'm curious about the methods you are using or plan to use for generating synthetic data.
We had a call this morning, but I was asleep because it was too early for me. So there was one of the first calls about the sub-consortium plus the external partners. I think the general idea is simply to use existing open source models. And the external partners is this EuroLLM consortium, which is University of Edinburgh, Unbabel from Portugal, and some other university, I forgot which. And they have 24 languages, they have a model for 24 languages, and I think they will use that because that also has the data available, so we know how it was trained. And this will be used for generating more data in the languages that they don't have. I'm sure because it's most of the people who are actually running this sub-task are academics. Promsit is a company, Unbabel is a company, but the rest are people from universities. They will want to do some comparisons, how well the data does compared when we generate the same, using the same methodology, but using Llama 3.1, or when we use DeepSeek or whatever, right? So depending how much of that capacity I showed you, the 3 million hours will be used for actually generating the data. We can also use some of it to do some experiments. But of course, to do the ultimate experiment is they generate the data and then do lots of experiments in building a model using the data, and for that we don't have the capacity. So we will have to find out, so the biggest task probably will be to find out some type of evaluation which will tell us what is a good way, what sort of answers your question, but in at least semi-rigorous way, based on some experiments. So we should have some of those data available within 6 months, because that's what we got to compute, and they will cut us off. So by December, mid-December, end of November, there will be, and we will publish the data. Some checking probably will be done, but there will be probably not part of the HPLT collection, because this is already the new project collection, but somehow connected to it. Yes.
Who's the supervisor at the University of Tübingen? This is the Alice Institute Tübingen?
Yes. Matthias Bettger is the person.
Okay. Okay, thank you.
And Frank Hütter, but Frank Hütter's affiliation now is Freiburg, but I think he still keeps, I think, both. And these two people were, you know, at the proposal writing at the beginning. Okay, so I guess.
Yeah, I think we should time for, let's see.